Lesson 7-3, Rational Exponents. Our essential question today is how do you solve an exponential equation? So we have one new vocab word, it's exponential equation. An exponential equation is an equation with an exponent in it. So exponential means that you are going to see an exponent in your equation. All right, our first slide says write as a radical and simplify. So radical form. We've talked about radical form a little bit, and we said that radical form means that you are going to have a root in it, like a square root, cube root, third root, fourth root, fifth root, something like that. So I want to remind you that we said an exponent of 1/2 is what corresponds to a square root. And an exponent of 1/3 corresponds to a cube root. And then we said anything bigger than that, 1/n, any number, is called an nth root. So basically what you focus on is the bottom of the fraction. So this one is a 2. It's a 2. I know the fraction isn't 1/2, it's 3/2. But that bottom number tells me that it is a square root. Then, what it's a square root of is 36 to the 3rd power. So that top number stays on the 36 as the power. The next one then, the 3 tells me it's a cube root. So this is just writing it in radical form. Cube root of 64 squared. I don't have to multiply that out. I could if I wanted to, but I don't have to because I'm just writing it in radical form. And then a 5th root of 32 to the 3rd. So that's taking something that's written in exponential form and just turning it into radical form. Now, the tricky part is I'm going to teach you how to simplify these without a calculator. We're going to stay focused on the bottom number in each of these fractions. And what we're going to do is we are going to change the number 36 into a power of 2. So 36 is 6 squared, 6 to the 2nd power. 6 times 6 is 36. So I'm going to keep my fraction, 3/2, like that. So far, hopefully that makes sense, that you can see why it would be equivalent. 36 is the same as 6 squared. Those are equivalent. So that's the only thing I've changed. Now, you know that when you have an exponent outside of the parentheses, that you can multiply it times the one inside. What happens when we multiply the exponent inside, which is 2, by 3/2, is the 2's cancel out. So that leaves me with 6 to the 3rd power, and that's 216. So I'm able to simplify that exponential form into a nice number, 216, without a calculator. The next one, same process. I have to match the denominator on my fraction. So I need something to the power of 3. So I look at this 64. And I think about powers of 3. I think about how to write it as a base to the power of 3. Like what number to the 3rd power equals that 64? Well, that's 4. 4 to the 3rd power. So these are equivalent now. Then I can keep my 2/3 fraction here. Cancel the fraction denominator with that 3. So then 4 to the 2nd power is 16. 16. All right, next one. 32, I need to write as something to the 5th power. Something to the 5th power. So, down here, I'm saying something to the 5th power has to equal 32. That number is 2. 32 is 2 to the 5th power. Cancel out my exponent, so now 2 to the 3rd power is 8. So that's taking something that's written in exponential form that looks really tricky, really confusing, and simplifying it. On this slide, we're going to do the exact same thing, only we're working with fractions. So that just means that we are going to simplify the numerator separate from the denominator. And I'll show you how to do that at the same time. So first off, let's start with focusing on the denominators here. So this is a square root, so just in radical form, square root of 1/25, and keep the 3, third power. Bottom number's a 3. Cube root, 8/27. Keep the top number to the 4th power. 5th root, 1/32. Keep the top number to the 2nd power. I'm not going to simplify from that radical form. Leave that radical form alone. That's just for if you're being asked to take something from exponential form and write it in radical form. So now to simplify, I'm going back to my exponential form. Focus on the denominators. Focus on the denominators. So the first one has a 2. So that means that I need something to the 2nd power for each of the numerator and denominator. So I need something to the 2nd power that equals 1, and I need something to the 2nd power that equals 25. So I think you know both of these. 1 to the 2nd power is 1. 5 to the 2nd power is 25. Then I keep my fraction out here, 3/2. I cancel the denominator and both of those 2's. They have to match to cancel out. They have to match. Now I'm left with 1 to the 3rd power over 5 to the 3rd power. 1 times 1 times 1 is 1. 5 times 5 times 5 is 125. So 1/125. All right, the next one. The bottom number is 3. So I'm going to need something to the 3rd power for each of my numbers. So I'm going to go down here and something to the 3rd power that equals 8. Something to the 3rd power that equals 27. 2 to the 3rd is 8. 3 to the 3rd is 27. So 2 and 3, cancel those 3's with my denominator and see what's left. 2 to the 4th over 3 to the 4th. 2 to the 4th power is 16. 3 to the 4th power is 81. All right, last one of these. Now we've got 5's. So 5th power. So down here, something to the 5th power that equals 1. Something to the 5th power that equals 32. 1, it's always going to say 1. It doesn't matter how many 1's you multiply together, it still equals 1. And 32 is 2 to the 5th. So these are 1 and 2. Cancel all of those 5's, and I've got 1 to the 2nd power over 2 to the 2nd power, so 1/4. 1/4. So that's how you simplify from exponential form when you've got a rational exponent. Now we're going to move on to solving some equations. Solving some equations. I think that you can probably figure out 2 of these. So I think you can figure out that the first one, x equals 3, because 5 to the 3rd is 125. And maybe you can figure out this bottom one, 16 to the 2nd power equals 256. The one in the middle, though, 243, that's not a power of 9. Like 9 to the 1st power is 9. 9 to the second power is 81. And 9 to the third power, if I multiply that by 9, I get 729. So what that means to me is that 243, it's got to be a fractional power of 9. So I need to teach you how to find that. So I want you to think about not the number 9, but think about the number 9 in a different way. So think about something that you could write as a power, like something to a certain power that equals 9. And I'm pretty sure you can come up with 3 to the second power. So then what we're going to do is we're going to write both of these numbers in this equation. We're going to write them both as powers of 9. So I'm going to write my equation over here. And I think I just said that wrong. We're going to write them both as powers of 3. Okay, so 9 is 3 squared. 3 squared. There's an x right here, so I still need that exponent that's an x. 243. 243. If I write out powers of 3, 3 to the first is 3. 3 to the second is 9. 3 to the third, 27. 3 to the fourth, 81. 3 to the fifth is 243. So writing these numbers 9 and 243 with what I call a common base. Common base. If I can write them with a common base, that common base is going to cancel out. It's going to cancel out. So if we write them with a common base, we can cancel out those common bases and then just set the exponents equal to each other. So I'm going to erase this, and I'm going to set the exponents equal to each other. 2x equals 5. And then solve my equation, and x equals 5 halves. So x equals 5 halves is my answer. So we are working with rational exponents, so you can expect when you solve your equations to see some rational exponents. So the value for x does not have to be a whole number. Now we have 3 more to try out like this. So the first one, hopefully you can figure out the common base. So the common base on this one should be the number 5. 25 is 5 squared. Notice the exponent is x minus 1 on that side. So keep that x minus 1 outside of your parentheses. The number 5 is just 5 to the first power. So now if I cancel my common bases, the resulting equation looks like this. We need parentheses around that exponent x minus 1 because you're multiplying it times 2. You're multiplying that whole exponent x minus 1 times 2 when you multiply exponents and distribute them. So distribute, and you get 2x minus 2 equals 1. Add 2, and 2x equals 3, and then divide by 2. So x equals 3 halves for the first one. All right, second one, 12 to the power of 2x plus 3 equals 144. For this one, my common base should be 12. So this side doesn't change, but 144, hopefully you know, is 12 to the second power. Cancel the common base and set the exponents equal to each other. So for this one, 2x plus 3 equals 2. Subtract 3, and 2x equals negative 1. Divide by 2, x equals negative 1 half. And the last one, 16 to the power of 2x minus 1 equals 8. You may think that you could use the number 4 on this one, but 16 is 4 to the second power. 8 is not a power of 4. So for this one, you actually need to use powers of 2. So 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So 16 is 2 to the fourth power. And then you've got your exponent, 2x minus 1. 8 is 2 to the third power. Cancel out your common base. Set the exponents equal to each other. Distribute again. And add 4. And divide by 8. So x equals 7/8. So on all three of these, we ended up with fractions for our answers. These problems are not ones that would be really easy to guess and just check on a calculator. So having a strategy, having a process to solve them where you're finding common bases is really the best approach. You don't want to be plugging fractions or decimals in your calculator and just trying to come up with the correct answer. Writing your powers out like this. If you're not good at memorizing your powers, just write them out. Write them out. And look at them, even if it means that it takes a little bit of extra time. You should be able to write a summary now, answering your essential question.